You know, we're surrounded by forces we can't see every single day, but none are quite as mysterious or as powerful as magnetism. It's this invisible push and pull that shapes our world in ways we barely even notice. So today, we're going to pull back the curtain and take a look at its secrets. And we're going to kick things off with a little puzzle. Just look at these rings. They're hanging in midair, completely defying gravity. No strings, they're not touching. So what's holding them up? I mean, for something to just float like this, there has to be some kind of upward force that's perfectly balancing the downward pull of gravity. What is it? Well, to solve this puzzle, we've got to understand the fundamental rules of the invisible force that's at play here, magnetism. So let's just break down the basics. All right, so the first rule is super simple, but it is absolutely crucial. Every single magnet, doesn't matter what shape or size it is, has two poles, a north pole and a south pole. And here's the thing, you can never have one without the other. This polarity, well, it's the key to everything that comes next. So how do these poles actually interact with each other? Well, it all boils down to one simple, elegant idea. Opposites attract and likes repel. A north pole will always pull a south pole towards it. We call that attraction. But if you try to push two north poles together or two south poles, they're going to actively push each other away. That's repulsion. Okay, so what makes that push or pull strong or weak? It really depends on a few key things. How powerful magnets are in the first place, how close they are to each other, and of course, which way their poles are oriented. And a big one is distance. The closer they get, the stronger that force becomes. And that brings us right back to our puzzle. The answer is brilliantly simple. The floating rings are magnets. They've just been stacked so that their like poles, so north facing north or south facing south, are pointed right at each other. That pushing away force, that repulsion, is just strong enough to perfectly cancel out gravity, and that's what lets them levitate. So now we know what's happening, but that just opens up an even deeper question, right? Why does this happen? I mean, where does this incredible force actually come from? To get that, we need to zoom in, way in. Okay, this is where things get really, really cool. Magnetism isn't just some property of the whole object. It actually starts at the atomic level. Every single atom in a magnetic material, like iron, acts like its own microscopic magnet, complete with its own tiny north and south poles. And this atomic level stuff explains a classic magnet trick you might have heard of. If you take a regular bar magnet and you snap it in half, you don't get one piece that's all north and another piece that's all south. Nope, you just get two brand new, smaller magnets, and each one has its own north and south pole. All you did was divide up that huge collection of tiny atomic magnets. Okay, hold on. If all the atoms in materials like iron are tiny magnets, then why isn't every piece of iron a magnet? Why doesn't a regular old iron nails stick to your fridge? Well, the secret isn't just having these atomic magnets, it's all about how they're organized. And that brings us to a really important idea, the magnetic domain. The easiest way to think about it is like a little neighborhood of atoms. It's a group of atoms that have all basically agreed to point their tiny magnetic poles in the exact same direction. They're a team, all working together. Now, in a normal, non-magnetic piece of iron, you've got tons of these domains, right? But here's the thing. They're all pointing in totally random directions. It's complete chaos. One points up, another points down, one points left, and because they're all scrambled, their tiny forces just cancel each other out. The end result? A net magnetic force of 0. But in a permanent magnet, something incredible has happened. All of those individual domains have been forced to align, to point in the same direction. So instead of fighting each other and canceling out, their forces all add up, combining to create one large, powerful magnetic field that we can actually see and feel. It's amazing. From chaos comes order, and from that order comes real power. And here's the really neat part. You can influence this alignment. If you take a strong magnet and bring it near an ordinary iron screwdriver, the force from that magnet will literally pull the screwdriver's random domains into alignment. And for that moment, just by being near the magnet, the screwdriver itself becomes magnetic. Okay. So we've gone from the atomic level up. How does this all translate into the real world, into technologies that actually change our lives? Well, understanding this invisible force has allowed us to engineer some truly amazing things. I mean, just look at the maglev train. It doesn't even have wheels. It uses the exact same principle we saw with our floating rings, repulsion, but on a massive scale. Incredibly powerful magnets on the train and on the track push against each other, lifting the entire train so it just floats above the rails. This gets rid of friction and allows for unbelievable speeds. And let me tell you, we have gotten so much better at making magnets over the years. We started with naturally occurring rocks called lodestones, then moved to the ferrite magnets you see everywhere. But now, we have things called rare earth magnets like neodymium. They are so ridiculously powerful. A tiny coin-sized one can lift a steel object over 1,000 times its own weight. It's all because their atomic structure allows for an incredibly strong and stable alignment of those magnetic domains. And this power, it's literally everywhere. It's in the simple magnet holding a grocery list to your fridge and the satisfying snap of a clasp on a bag. But it's also the driving force in the motors of electric cars, it's essential for medical imaging and MRIs, and of course, it's what has guided travelers across the globe for centuries with the compass. So let's loop all the way back to the beginning. Those floating rings, not magic at all. They're permanent magnets. They're materials where billions upon billions of atomic domains are all locked into alignment, working together to create a net magnetic force that's strong enough to push back against another magnet and win the fight against gravity itself. So from the simple rules of opposites attracting, all the way down to the precise alignment of atoms, we've figured out how to harness this invisible force to achieve some incredible things. We can lift an entire train right off the ground. It really makes you wonder, doesn't it? What seemingly impossible challenge will we solve next by mastering this fundamental force of nature?